You're a mountaineer, tasked with mapping an uncharted mountain range. But this isn't any ordinary range, it's the home of a rare, elusive creature, the Quantum Yeti. The Quantum Yeti is unique. It can appear at different places and heights at any time. Your challenge is to construct a way to predict the most likely locations of the Quantum Yeti, given its bizarre characteristics. To do this, you develop a unique form of cartography. You start with a basic map of the mountains. Then, instead of marking a single, precise location for the Yeti, you decide to indicate areas of probability, which denote where the Yeti is likely to appear. You imagine pouring sand onto the map, with each grain representing a point of probability where the Yeti might appear. Over time, you notice that the Yeti seems to appear more frequently in certain areas, for example, around a particular cliff or a certain cave. These areas naturally accumulate more sand, building up into sand mountains on your map. These mountains of sand represent your wave function, the peaks indicating the areas where the Yeti is most likely to appear. But the Quantum Yeti is not stationary, and its favorite locations seem to change over time. The sand on your map begins to shift. A gust of wind might blow some sand from one mountain, depositing it in a valley, or a new mountain might start to form in an area the Yeti has begun to favor. These shifts in the sand across the landscape of your map represent the time evolution of the wave function. You realize that you've created a dynamic, evolving representation of the Quantum Yeti's location. The sand map cannot tell you precisely where the Yeti is at any given moment, but it provides a probability landscape that's continually updated as the Yeti moves and behaves. The peaks and valleys of sand are ever-changing, just like the peaks and troughs of a wave function in quantum mechanics. In this way, your sand map serves as a beautiful, tangible model of the abstract wave function, representing the uncertain, probabilistic behavior of quantum particles, or, in this case, the Quantum Yeti. Subscribe, like and share for more content.